Hello, my fabulous chemistry students. Video number 8. We're going to move on to trend number 2, electronegativity. Big, bad word. We need to figure out what that means. That's what this video is all about. And, of course, how do the trends change? Well, are all the elements, do you think, going to have the same electronegativity? Well, absolutely not. Electronegativity. Do you think we're dealing with electrons? Yes. Do all atoms have the same amount of electrons? No. So electronegativity is going to change. Basically, what it is the desire to gain electrons. How bad does this element want an electron? And remember that whole octet rule thing? That's going to come into play a little bit. You could think of it as the greediness. You know what I mean? Is the atom going to act like Scrooge or the Grinch? You know what I mean? Is he going to be greedy? So overall, nonmetals gain electrons, and they want to achieve the octet, which is 8 valence electrons. So they have what we call a high electronegativity. They have this desire to gain electrons. And if you think about it, like I said in a previous video, chlorine, for instance, chlorine has 7 valence electrons. It wants to get to 8. All atoms want to get to 8. What is it easier to do? Gain 1 or lose 7? It's actually easier to gain 1. So it is a high electronegativity. It wants that electron real bad. Metals, of course, with their loosey-goosey sea of electrons, tend to lose electrons. So if they lose them all the time, that's how they're going to get to their octet, and they have a low electronegativity. They really just don't want them. So our values on table S is from 0 to 4. Okay? The most electronegative atom, of course, is going to be fluorine. And the reason why that is if you look down all of the halides, 17, fluorine, chlorine, bromine, and iodine, right? Well, fluorine has its 9 protons in the middle, 9 pluses, and 2 energy levels. And then underneath it, chlorine has 17 protons, but it has 1, 2, 3. So if I'm an electron out here, and both of these have 7 valence electrons and wants one of them, let me draw that electron right in the middle so it doesn't look like I know the answer already, even though I do. Which one's going to feel the magnets better? Right? This electron's going to feel the magnets of who better, or hence the nuclear charge of who better. Now, even though there's 17 pluses down here, I have this extra 17, right? I have that extra electrons around it too. 17 total electrons. So I'm actually going to be able to feel that plus 9 better. 9 is going to be able to get that electron better because it has less shielding. Okay? Least electronegative atoms are. Well, that's going to be bottom left-hand corner. We're going to call that francium. And then, so francium is something we don't find all the time, so cesium could be the other one. All right, cesium. Okay? Francium is A. Mr. Milks is the worst spelling teacher there is. Francium with an A. How about I delete it and write it again slow, Mr. Milks, so we can read it, please. Please, Mr. Milks, write that again. Francium, F-R-A-N-C-I-U-M. Francium. Now we spelled it right. Beautiful. All right, here we go. Going across a period, my electronegativity will increase. The reason that is because I've increased my nuclear charge, of course, and the shielding does not increase. So those pluses, like I said before, I can feel that nucleus that wants that 1 electron really bad. When I'm left over here, sodium has 1 valence electron. Does it want to gain 1 electron? Well, it needs to gain 7. How bad does it really want to gain 1? Not at all. But chlorine here has 7 valence electrons. How bad does it want that one? It wants it real, real bad so it can get its octet full. Okay? Now let's go down. As I go down a group, the electronegativity is going to decrease. The reason is this big bad shielding. We're going to find this all the time. So again, in this group here, let's deal with group 17. Fluorine, I really want this 1 electron to come in to be full, right? Well, here is a good example. If I was this 1 electron to come in here, do you see all the black dots for chlorine? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in that shell, that inner shell, those kernel electrons that are shielding this outside ring, if you will. In fluorine, there's only two. There's only two kernel electrons shielding, and the rest are in the valence shell. So there's not a lot of shielding going on. This lone electron floating around is going to feel this plus 9, way better than this plus 17 because this one's got all these electrons floating around. That, in a nutshell, is what shielding is. So I hate to keep blabbing on and on and on. But this shielding is a big deal, and you're going to find it does have a lot to do with the trends. So now we know electronegativity changes as we go up and down and as we go across. You guys got tons of practice to do. I expect you to do it. Good day. May peace be with you.